So in example 4, we're going to clear out this embedded fraction. So we're looking at this embedded fraction here of divide by x minus 1. And we want to clear out that embedded fraction by multiplying by that divisor. So we have a divide by x minus 1 that we want to undo. So we're going to multiply by x minus 1. And as long as I balance the fraction, I can do the top and bottom. That will work. And nicely, what's going to happen is, in both cases, in the numerator and denominator, the x minus 1 factors will cancel out. So multiplying this through, I need to make sure I distribute to both terms. So I end up with x squared minus, actually I'm going to do an extra step here. So although you can compress steps here, I'm going to do this extra step. I have my original x, and then I have my x minus 2. Sorry, x minus 1. So I'm going to have that x minus 1 factor here, and then minus. These x minus 1's cancel out, so I'm just left with minus 4. That's my numerator. In the denominator, I'm going to do the same thing. I'm going to expand this. So I'm going to distribute x. It's going to multiply the x minus 1 from the bottom. And then we're going to end up with plus. The x minus 1's cancel out. When I multiply the fraction, I'm just left with 6. Now, I just remembered now I forgot to state my restrictions at the very beginning. I really should have stated my restrictions before I cancel anything. So x is not equal to negative 1. Okay, so then I can expand out these brackets and simplify this. So I have x squared minus x minus 4 in the numerator. I have x squared minus x plus 6 in the denominator. Now we do still have to account for this being a divisor, so we still need to state restrictions for that. However, this happens to not be factorable, so we can state that as x, I'm just going to write that in red. Okay, we can state that as x squared minus x plus 6 is not equal to 0. And since it's not factorable, we express it in that way. Now, it just happens that if we test this in the discriminant, this does not cross 0. It does not have any zeros. Therefore, we don't have to worry about this equaling to 0. So this is actually redundant. We actually don't, technically, we don't need that. For the rest of this here, I'm checking to see if it's factorable. It's not factorable, so that must be my final answer because there's no common factors I can cancel out. Again, I want to reiterate and emphasize, do not cancel plus pieces. Okay, they do not cancel out. So please never do that. When we have pluses and minuses, they are not factors and they don't cancel. For this one here, we have two denominators, m plus 3 and m minus 4. Well, to get rid of the n plus 3, I need to multiply by m plus 3. But if I do that, I need to balance the fraction and multiply the bottom by m plus 3. But I also want to get rid of the m minus 4. So to get rid of the m minus 4 on the bottom, I need to multiply by m minus 4. But I can't just multiply the bottom without balancing the fraction. I need to do that in the numerator as well. So what we end up doing is we multiply by the lowest common denominator. And some parts will cancel out, some parts won't. So when I multiply this out, I have to remember that all of this gets distributed to both parts of this fraction. So I'm going to end up with 3. Nothing cancels with the m plus 3, so I end up with m plus 3. Nothing cancels with the m minus 4, so I end up with an m minus 4. Plus, here the m plus 3's cancel, So I get rid of the divide with that times by n plus 3. However, we have to remember that the n minus 4 did not cancel in the numerator, so we still have that factor left over. In the denominator, I have to remember to do the same thing, that both of those terms get distributed to the fraction and the 1. So I end up with the 1 times, well, nothing cancels with m plus 3. So I have an m plus 3 there. The m minus 4, nothing cancels here either. Plus, in this case, the n minus 4's cancel out. We're left with, so we have no more divide there. We have the 2 times 2. And since the m plus 3 did not cancel, we're going to have an m plus 3 here. Now at this point, I've gotten rid of my embedded fractions. Again, I forgot to state my restrictions. I really need to make sure I state my restrictions first. X is not equal to -3, +4. That always has to be done before any canceling. So I should really always do that at the very beginning. So once I've done that, I can now expand this all out. M squared minus 1m minus 12 plus 8m minus 32 in the numerator. I end up with m squared minus m minus 12 plus 2m plus 6. Again, I can't cancel anything out till I combine like terms and factor this. So I have 3m squared minus 3m minus 12 plus 8m minus 44. In the denominator, m squared plus 1m minus 6. Okay, so I need to then combine my like terms. The denominator is factorable. So here I'm going to plus 5m minus 56. Just double checking my work there. That looks good. The denominator I'm going to factor to m plus 3 m minus 2. Okay, so in this case here now, I have to account for the denominator being restrictions. So that denominator is a restriction. The m plus 3 I've already stated. So I need to add my restriction. These are m's here. I already have the m, the -3. I have to add the restriction that's generated, which is x or m cannot equal to +2. Okay, and that comes from, let me just highlight that too. That one there generates the new restriction here. I'm going to factor the numerator if I can. So I'm going to check to see if the numerator is factorable. I'm not sure if it is. So we have 3m squared, -56. Multiply that together, I get 168 m squared negative. Okay, and I need to know if 168 has factors that have a difference of 5. Well, 168, that looks like it's 7. 7 would be a factor. 7 times 24. No, that won't work. 14 times 12. Okay, 14 times 12 would be a factor of this, so that doesn't work. And it looks like maybe that's our only choices. So it looks like this is not factorable. So I can leave it like that. And so that ends up being my final answer. We don't have any common factors that will cancel out with the numerator and denominator.